So our objective today is to apply the Pythagorean theorem of two-dimensional shapes in problems and real-world applications. So anytime you hear that real-world applications, you're basically talking about a word problem that utilizes the same idea. So the key things that we're going to look for when we talk about Pythagorean theorem, so let's go. Okay, we know that it looks like this, a squared plus b squared equals c squared. Okay. So some key ideas that we know about Pythagorean theorem is number one, it's right triangles only. This doesn't apply to isosceles triangles or scalene triangles. Only if there's a right angle, then we can apply the Pythagorean theorem in it. The A and B are the legs. And we can also think about A and B being the smallest and middle numbers. So oftentimes they'll just give you three numbers, or two numbers and a mystery. And then the C is the hypotenuse. And the hypotenuse is always the longest side. So if I drew a picture of a right triangle, we have A, B, and C. Now, I just, by nature, apply the smallest side to A, and the middle side to B, and the longest side is C. Now, that's going to really come into play when we talk about the converse of the Pythagorean theorem. So if you kind of get a system down, how you label A and B, then you just keep consistent every time you solve a problem. Okay? Okay. Okay, and I do want to again go back and mention that when you are looking in your book online on myhrw.com, that you're looking at lesson 12.1. Okay, so all the homework, and we'll talk about what is YT, GP, and IP. We'll remind ourselves about that. It all comes from lesson 12.1. Okay. So let's do a couple of problems, and the directions that you might see, maybe something like find the length of the missing side. Notice it doesn't say missing hypotenuse, missing leg. It says side, which means it could be any one of the three sides of the triangle that could be missing. So a lot of times what they do is they give you a picture. Most likely you will see units of measure, and your answer will also need to include those units of measure. All right, so of the triangle ABC, which one is missing? Okay, yeah, directly opposite the right angle is the hypotenuse, so that would be the C is missing. So we have our formula. A squared plus B squared equals C squared. And because we're solving for c squared, we can use what's called the symmetric property, which says let's just rearrange what was on the right side of the equation to the left, what was on the left side of the equation to the right. Because if I'm not going to actually solve for c squared, I'm actually going to be solving for c. So I have some additional math to do once I put numbers in. So let's go ahead and arbitrarily assign a value and b value. So who do you want to be a?
7.
Okay, so we'll let a be 7, which means the 24 has to be the b. Okay. So we get c squared equals a squared, which is going to be our 7. Now I'm going to include labels in this just so you can watch what's happening to them. And then the b is the 24 inches squared. So what's 7 squared?
49.
49. It's off of our list. Now when I square the 7, I'm also squaring the inches, so I get 49 squared inches. Now, does anyone know what 24 squared is? That's one off of our list.
576.
Okay, 576. Very good. Sometimes we see things so often that we just memorize them. And again, inches squared is going to give us square inches. So notice that the labels match over here. I have square inches and I have square inches, which means I have like terms. So I can actually add those together. And I get c squared equals, and I'm just going to do it underneath here. So I get a 5, 11 and 1 is a 12, and I get this. 625 square inches. But that says c squared equals 625 squared inches. Aaron, you writing everything? Okay. I want to figure out what c is. So we talked earlier in the quarter, how do I get c squared to become c? What can I do that we've talked about in the past? Say it again, Jenna?
Square root.
Yeah, I can take the square root. So, but if I take the square root of one side of an equation, I have to take the square root of the other side. That's about another property of equality. Anytime I have an equation, I have to treat both sides of the equation exactly the same. But what do I get when I take the square root of c squared? I get c. Okay, now I'm going to break down the next bit into two parts. What's the square root of 625? In other words, what number times itself gives me 625? Joan again?
25.
Yeah, very good. And what do you think I get when I take square inches and take a square root? I just get plain inches. So the answer is 25 inches. What I'm not going to do is to write the answer with a variable in it, okay? And that's how I would wind up this problem. All right? All right, everybody good? If we're taking the square root of this, we're actually taking the square root of 625, and we're taking the square root of inches squared. And anything that has an exponent of 2, when I take its square root, the exponent gets canceled out. So that's why I get inches as part of the answer. And the square root of 625 is 25. All right, Aaron, you ready, bud? Okay. So let's do another one like that, and then I'll give you a good word problem. How about if we tell you this time in this triangle, we're going to give you the hypotenuse. So we'll make it 15 centimeters, and we'll tell you one of the legs is 12 centimeters. So the formula isn't going to change. It's always going to be a squared plus b squared equals c squared. Now this time, I'm going to be solving for an a or a b. So the c squared can stay where he's at. We've already got the hypotenuse, which is opposite the right angle. Now, do we want to call 12 the a or the b? What do you guys want to do? Okay, I heard b first. So that's going to make this guy a. So we're going to actually be solving for the mystery a number. So what we do is we substitute in the values. We've determined that b is going to be the 12 centimeters. So again, I'm going to do it with labels. Normally I wait and I put my label in the answer. But again, what I'm noticing is that sometimes you guys are having a hard time knowing what to write as the label because you're not following the same math that we're doing to the numbers we can do to the variables at the same time. So on this guy, what's 12 squared?
144.
144. And centimeters squared would be squared centimeters. So that 12 centimeters squared gives me 144 squared centimeters. All right, what's 15 squared?
225.
Somebody remembered his squares. Good job. And then we square the centimeters as well, and we get that. Now, I'm trying to get A by itself, so I'm going to have to do a little bit of what we call opposite operations. So the opposite of adding 144 squared centimeters would be subtracting it from both sides. And you're going to be expected to show me all of these steps. And we get A squared equals, and then we do the subtraction. So we get a 1, we get an 81 squared centimeters. But again, the problem didn't ask us to solve for A squared. It wanted to know what was the length of the missing side, not the missing side squared. So what are we going to do?
9 square root.
We're going to have to take square roots. So we'll take the square root of both sides. What's the square root of A squared?
9.
A. What's the square root of 81?
9
What's the square root of centimeters squared?
centimeters.
Plain old centimeters. So your answer is
9 centimeters.
9 centimeters. Okay, so when it comes to word problems in Pythagorean theorem, they break down into a group of problems that you see over and over again. A lot of them have to deal with a ladder leaning against a building. They deal with a baseball diamond, because all of the sides, you meet at right angles when you go from base to base. You have a rectangle, or like in the example we had at the beginning, that video we watched, the real world video, it showed televisions which are shaped like rectangles, and using the diagonal as the actual measurement of the size of the television. A lot of taking a wire from, let's say, some sort of pole where you're connecting either cable or telephone or something, and you have to take it to the house. So anytime you have something high meeting with the ground at a distance, you're going to create this right triangle. So anytime you have a word problem, if they don't give you a picture of it, you need to draw a picture of it. You need to discover where the right triangle is. Once you discover it, then you're good. Okay, so when it comes to these problems, I'm going to ask you guys to round the answers to the nearest tenth, because when we talked about estimating square roots, we talked about rounding to the nearest tenth. So we're going to use that same strategy here. And so what we have is a 10-meter ladder is going to be leaning against a building, and the bottom of the ladder is 5 meters from the building. And how high is the top of the ladder? So first we have a building, right? And the building sits on the ground. Okay. And then we bring in a ladder, and we lean that ladder so that it touches the building, but it also needs to make contact with the ground. Otherwise, we couldn't actually climb up the ladder. If the ladder was flush against the building, as soon as you tried climbing up a couple rungs, you and the ladder would fall backwards. Okay, so you got to have some distance on it. So where is the right angle in this problem? Yeah, where?
The house between the ladder and the house.
Right here is where it's always going to be. It's where the house meets the ground. Okay. Now, they mentioned that the ladder was 10 meters. So where do I put the 10 meters in this drawing? Where's the 10 meters going to go? Okay, yeah, but where in that drawing would it be?
Against the ladder?
It's the ladder, right? So there's the 10 meters. And then it said the bottom of the ladder is 5 meters from the ground, or from the building. So where would the 5 meters go? So if you look at the bottom, here's your 10 meters. And so the question was, how high is the top of the ladder? So basically, we're looking for this height from the bottom of the building to where the ladder touches it. And we'll just call it X for this moment, okay? So we're going to define what X is. So this is what we do whenever we do word problems. We choose a variable and we define what it is. It's the height of ladder on the building. So if I had to assign A, B, and C to my diagram, what would be A, what would be B, and what would be C? Okay. Okay, Victoria, what's one of them? You just tell me one. Who's A, who's B, who's C? Pick one of them.
C is the 10 meters.
Okay, easy. We got the C is right there. Okay, Bailey, who's A, who's B?
5 is
Okay. So Kina, who gets to be B now? Yeah, that's all we have left, right? So we still use Pythagorean theorem because of the right triangle. And we're just going to plug in what we know. What we said is that the A was going to be that 5 meters. B, however, is going to be used with the variable x. And then the C is the 10 meters.
Would you put x meters squared?
No. We're not going to add any label. Solving this problem will get the label on our mystery fellow. Okay? All right, so let's go ahead and do some math here. All right, what's 5 squared?
25.
And meters squared? Kind of a trick question there, right? And then we just square x and we get x squared. And what's 10 meters squared?
100.
And the
100 meters squared.
100, and we get square meters is how we read that.
Hey, Jonah.
Okay? So now, x is what I'm solving for, but there's math being done to the x. So how do I get rid of that 25 square meters? Let me choose. Giovanni.
What?
How do I get the x squared by itself?
You subtract 125.
Ooh, I don't have 125 to
I mean-
subtract.
You subtract 25 and 100.
Okay? So what I want to do is whatever's on the same side as the x squared, that's the thing I want to get rid of. Because he's positive, I'm going to subtract him from both sides. Now again, normally I don't do math with labels, but again, I really need you guys to see where the labels for the answer come from. So what's 100 take away 25?
75.
Yeah. And then we get square meters. Okay? But we're not being asked to solve for x squared. Jacob?
Yep.
Pay attention. We're being asked to solve for x. So that's where taking the square root on both sides, comes from. And, so square root of x squared is? X. And, can I take the square root of 75? Is 75 a perfect square? It isn't. And then square root of meter squared? Meters. So here's where we're going to use our other skills. We're going to take this guy, and we're going to remind ourselves how to do the square root. If you don't remember, we do still have in the homework that dealt with estimating square roots, we had a really good video from, I think it was South Bend, South Fork, North Fort, I can't remember anyway. The tutoring company that we found a really good video on. And what they said to do was to figure out what are the two perfect squares that number falls between. Jonah.
8 and 9.
Okay, nope, those aren't perfect squares.
Oh, sorry, 64 and 81.
Okay, so 64 and 81. But remember, we're not looking for 75 and the perfect squares between. We're trying to do square root of 75. So we're going to take the square root of those. So that's where Jonah came up with the 8 and the 9. So our number is somewhere between 8 and 9. So we say, well, it starts at 8 and then it ventures on. So how do we figure out the ventures on? What we do is we take our number, 75, and we're going to subtract the smallest of the perfect squares from it. So that gives me 11. That's going to become the numerator of the fraction bit I'm going to add to that 8. And then I take my two perfect squares and subtract them. So I want to know what their range is, basically. And I get 17. So now, more math that has to be done is, what do I get? No, guys, this is nothing beyond your capability. Believe me. And I'm going to divide 11 by 17. So I put in a decimal point, bring in a 0. 17 goes into that, let's see. 9 is going to be way too much. 7 is going to be over 110, so it's going to go 6 times. So I get 42, 7 times 6 is 42, and then we have 6 times 1 is 6 plus 4 is 10. Now here's the beautiful thing. What did I tell you we were going to round this to? What did I say? To the tenths, right?
Yeah.
So I only need to do 2 rounds of division after the decimal point so that I'll know how to round to the nearest tenth. So I don't have to keep dividing and dividing and dividing. So how many times does 17 go into 80? Well, let's see. 4 times 68, 5 times,
4 times.
oh, yep, it's got to be 4. So that gives me, let's see, 68 with a difference of 12. So this is where I stop. And at this point, I'm at 8.64. I'm going to go ahead and take that, and I'm going to round it to the nearest tenth. What's the 4 going to do to the 6? It's going to keep it the same. So what we have is x equals 8.6 meters. Now, when we write the answer to a word problem, we do not include a variable in it. So my final answer is 8.6 meters. And I just boxed that up. Now, I watched a couple of you stop paying attention because you're like, this is more than 2 steps, therefore I'm not going to pay attention to this. I hate to tell you it's going to be on your benchmark and it's going to be on the SBAC, and it is a requirement that you figure this out. We've given you practice over this, and you also have videos to watch on this. So don't tell yourself you can't do it, because then you're telling yourself you're not capable. And that's not what we're thinking about. Okay? You are capable of doing this. You just have to push yourself. Okay?